Welcome to Dr. Yap Banha's Problem Box. In today's lesson, we are going to solve a problem. Let's see what problem we have for today. Oh, this is our problem for today. In today's problem, we are trying to figure out if I have two cubes, we call them dice because we got numbers on them, 1, 2, 3, 4, 5, 6, and we put the cubes together. Are you able to see that we can see a lot of the numbers, but there are some numbers that we cannot see? That's right. I cannot see the two numbers that are hidden in between the two cubes. We can see all the numbers except the two that are hidden between the two cubes. Our problem today is to figure out what is the total of those two numbers. That's our problem for today. If we know that at this end, the number is 3, and at the other end, the number is 1, if we know that information, can we find out the total of the two numbers that are hidden? I think the total is 10. Is the total of the two numbers really 10? When you add the two numbers up, are they really 10? 6 and 4. 6 and 4 is 10. That's our problem for today. When you put the two dice together, without looking, just any way you like it to be, and you look at the number at the end, and it is 1 at this end, and it is also 1 at the other end, I can tell you that the hidden numbers add up to 12. Is it true that two numbers add up to 12? 6 and 6. Is 6 and 6 12? That's our problem for today. Have you tried to solve the problem from Dr. Yap Banha's Problem Box? How far did you manage to go? The problem is, put two dice together without looking. Can we tell what is the total of the two numbers that is hidden right here in between the two dice? By looking at the number at this end, 5, and the number at the other end, 6. I think the total is 3. Let's check. Is the total 3? 1 and 2 is 3. So, when the numbers at the end are 5 and 6, the total that we managed to get is 3. What else did you get? Let's try another one. Just put them together. If the numbers at the end, one of them is 5 and the other one is 6, I think we don't even have to try because this is what we got a while ago. For sure, the two numbers in the middle add up to 3. 2 and 1 is 3. So we can try it again and see if one of the numbers at the end is 2 and the number at the other end is 6, can you tell What is a number that's hidden in between? I think it's 6. Am I right? 5 and 1 is 6. I am right. So when the numbers at the end are 2 and 6, the number that is hidden is 6. Let's try one more. Say we have this. At one end, the number is 4. At the other end, the number is 1. Can you tell what is the total of the hidden numbers? I think it's 9. Is it really 9? 3 and 6 is 9. So when the numbers at the end are 4 and 1, the hidden number is 9. Do you see a pattern? What pattern do you notice? Are there other patterns that you're able to see? Can you talk about this with your friends if you're in class? Or with your parents if you're at home? Or perhaps with a teacher if you're working with a teacher? What are some interesting patterns that you manage to see? What did you notice? Somebody said they noticed that I got 3, 6, 9. Is that a pattern that will always happen? Someone else say they noticed something interesting about the numbers I have. The numbers that we have at the end and the numbers that we have hidden. Is there anything interesting about numbers like 4 and 1 and 9? What about 2 and 6 and 6? And 5 and 6 and 3? Is there anything interesting about the 3 numbers in the first row? 5, 6, and 3. 2, 6, and 6. 4, 1, and 9. Is there anything that is the same about the 3 numbers in the first row when you compare them to the 3 numbers in the second row and the 3 numbers in the third row? What is the total of 4, 1, and 9? Did you say 14? Is 4, 1, and 9 14? 1 and 9 is 14. 1 and 9 is 10. 10 and 4 is 14. What about the total of the 3 numbers here? 6 and 6 is 12. 12 and 2 is 14. What about the 3 numbers in the first row? 6 and 3 is 9. 9 and 5 is 14. Is there anything interesting you notice about the total of the 3 numbers here compared to the 3 numbers here compared to the 3 numbers here? Is that a pattern that always happens? So I noticed 2 patterns. I'm just wondering if they always happen. I noticed that I got 3, 6, 9. Will I always get a pattern like that? I also noticed that there's something interesting about the three numbers that we have each time. The numbers at the end and the numbers that are hidden. Can you talk about this with your friends if you're in class? Or with your parents if you're at home? Or perhaps with a teacher? Go on. Five, 6, and 3 is 14. 2, 6, and 6 is also 14. 4, 1, and 9 is also 14. Can I make use of that to figure out what is the total of the two hidden numbers? So, if this number is 3 and that number is 4, that's already 7. And since the total is 14 and those two add up to 7 already, I know the number that is hidden must be 7, because 7 and 7 is 14. And let's check. Is the total indeed 7? That's our problem for today. If you want to challenge yourself, why don't you try this? Why don't you ask yourself, I wonder if we can do the same trick using 3 dice. If I put 3 dice together and I know that this number is 4 and that number is also 4, is it possible to tell the total of the numbers that are hidden? In this case, there are 4 hidden numbers. If you find today's lesson quite easy, you can challenge yourself by extending the problem to make it a 3-cube problem using 3 dice. What about 4 dice? If I know the number here is 1 and the number here is 4, can I tell how many hidden numbers are there? With 2 cubes, there were 2 hidden numbers. With 3 cubes, there were 4 hidden numbers. With 4 cubes, there are 6 hidden numbers. Can we tell the total of the 6 hidden numbers if we know that this number here is 1 and that number here is 4? If you find today's lesson quite easy, you can challenge yourself by asking yourself, what if we have 3 dice, 4 dice, 8 dice? In fact, any number of dice. Are we able to tell for 10 dice how many hidden numbers are there? And can we tell the total of all the hidden numbers? Why don't you challenge yourself? See you next time at Dr. Yap Banha's Problem Box.